Does this also make you nervous? I have a 7-year-old daughter who enjoys candy and trusts people. Be careful. Hey, 7.2 is talking about membrane structure, and the whole theme of selective permeability means some things can get in, some things cannot directly through the membrane. Some things need help getting through the membrane by way of a protein, and so it's all about small uncharged molecules. Here are some examples of these small uncharged molecules, such as oxygen gas, carbon dioxide gas, nitrogen gas, and of course fart gas, methane. Those are all small and uncharged. They can get through the membrane without needing any assistance whatsoever. Your book will go on to tell you that a lot of hydrophobic or nonpolar molecules are able to, if they're able to get by the hydrophilic portions on the either end, they can just shoot right through the middle. There's no big barrier there in the middle to stop them from just being diffused through the membrane. We'll get into diffusion osmosis in a minute. But here's an example of a nonpolar molecule, one that has a lot of carbons and hydrogens. If you notice here, there are no electronegative atoms or elements here, such as nitrogen or oxygen, that are going to unfairly or unequally pull an electron towards it and cause more of a negative charge in an area. We've already talked about polar and nonpolar molecules. And here's an example of a polar molecule. This is actually glucose. It's a super important molecule that needs to get into every one of our cells along with oxygen so that the mitochondria can create ATP so that the cell can do all of its processes. These guys have a hard time getting through the middle of the phospholipid membrane. It's nonpolar, so it just gets blocked there and it gets rebounded out. So you're going to see that these guys need a protein in order to assist them in getting through the membrane to the inside of the cell, these glucose or very polar molecules. Owing to all that I've just said, what would the answer be here? Well, there's two different types of membranes that assist molecules in getting through membranes. The first type is called a transport protein, and these guys are going to allow hydrophilic substances such as glucose to get through the membrane. Example of a transport protein is a channel protein, and your book's going to talk about one called aquaporin, and basically it's a pore for water, aquaporin, and it allows the hydrophilic, obviously, water molecule, which is polar, to get through the membrane really quickly. In fact, so quickly that they allow up to 3 billion water molecules per second. Why would you need water into cells? Well, for instance, for hydrolysis, to use water to cut things. Your cells are always recycling stuff in lysosomes, and it needs water to cut all those peptide bonds between, say, amino acids or nucleotides. Here's another type of protein called a carrier protein. A carrier protein is a type of transport protein, and it's going to help bigger things get through, such as glucose. Also, it's going to help charged molecules such as ions, such as sodium and iodine items and potassium ions to get through. Those are charged, so they're not just going to freely move through the phospholipid bilayer. Make sure that you are able to distinguish between these two types of transport proteins. Thank you.